Welcome to BKW Physics. I'm Mr. McConley, and today we're going to focus on combo circuits, combination circuits, which means we're combining the series aspects and the parallel aspects into one circuit. Let me start with this idea here. If in blue here, if we had a circuit and it consisted of 3 resistors, this would be a parallel circuit. But once we add on a resistor here, now this part is series because all the electricity, all the current goes through this resistor, and then it has a choice to branch off into those parallel circuits. So now it's a combo circuit. The basic plan is that you want to combine the parallel part of the circuit. So in essence, what you're doing is you're making it into where if we call this one R2, R3, and R4, this now is a combo of R2, 3, and 4. So you've combined these, and now you can just treat it like a series circuit. So keeping that in mind, let's approach the problem I have written up here in black. So what I've given you is I've given you R1, 2, 3, 4, and 5. I've listed them here. I'm basically going to solve for every piece of this circuit. Now, the first thing I want to do is I want to combine these 3. I want to combine those 3. And those 3 right now are in parallel. So what I'm thinking about is to find the total resistance of these, I'm going to treat it like a parallel circuit. So I'm going to call it R3, 4, 5. And that would be 1 over R3 plus 1 over R4 plus 1 over R5. Now, the numbers play out something like this. It's 1 over 30, 1 over 30, and 1 over 30 ohms. So we got 3 over 30 ohms, and that's equal to 1 over R3, 4, 5. So R3, 4, 5 is actually equal to 10 ohms. Now I know this right here is 10 ohms. And in essence, what I've made my picture into is a picture where you have R1, R2, and R3, 4, 5. So R1, R2, R3, 4, 5. Now it's a series circuit, so basically when I find the total now, the total resistance, I can just add R1 and R2 and R3, 4, 5. So the numbers would play out like this. 5 ohms, 10 ohms, and this one here, which was also 10 ohms. So I would get a total resistance for this circuit of 25 ohms. That's a total resistance of 25 ohms, and that would go right here. Now what that does for you is that opens the window to the next step. I have 25 ohms of resistance. I have 50 volts total. So I can get the total current. So the total current would be the voltage total over the resistance total. The voltage total is 50, the resistance total is 25. I divide, it goes in 2 times. So my total current for this circuit is 2 amps. Now the next thing you got to think about is if the total current is 2 amps, then how much of that current is going through these 2 resistors? And I think you can realize that the total current goes through both of those. It has no choice. So now you know that the current in number 1 and the current in number 2 is 2 amps. Now let's change gears for 1 minute. If you have 50 volts here, and you have a resistance of 5 and a current of 2, how much voltage got used up by this particular resistor? So what we can do is we can say the voltage that got used up by the first resistor is the current at the first resistor and the resistance at the first resistor. So 2 amps and 5 ohms, we get 10 volts are used up by the first resistor. Okay? 10 volts are used up here. How about the second resistor? Again, we have 2 amps So let's do the same process. Voltage 2 is I2 times R2. We got 2 amps, and we got a resistance, in that case right there, of 10 ohms. So we got 20 volts gets used up on the second one. Now this is key here. If you started out with 50 volts, so think of 50 volts going this way, and you used up how much? 10 minus 10. Well, what do you got left as you're going this way? Well, you only got 40 left, 40 volts. Now you get to this resistor, and you use up 20 volts. How much do you have left as you leave the second resistor? Well, you have 20 volts left. And one of the key concepts in parallel circuits, because now the voltage is going into a parallel setup, is that voltage in parallel is equal. So V3, 4, and 5 are going to be equal to how much voltage came in. So since 20 volts came in, these are all 20 volts also. And that leaves us with the details of finishing this up. Because if we know that the voltage is 20, for instance on V3, on R3, the voltage is 20 right here. And we know that the resistance is 30, we can get the current. Because we can simply do I3 is V3 over R3. We can do the same with I4, being V4 over R4. And we can do the same with 5, being V5 over R5. The numbers would play out like this. It would be 20, 20, and 20 for the voltages. The resistances would be 30, 30, and 30. So you can see that when you divide, you're going to get 0.6 repeating for each of these. So, you have found the current in each one of these to be 0.6 amps, 0.6 amps, 0.6 amps. So at this point, you have solved for each of the pieces of this circuit, and you have learned combo circuits, physics.